All right, welcome back to Mining Now. Today on the show, or tonight, depending on when you're streaming this, we have got a guest that's coming on the show for the first time, and he's also brought a client with him we're going to spend about 10 minutes with the client on the show as well. So it's a very exciting way to do it because we can talk technology all we want, but there's something different when someone who's actually adopted the technology comes on the show. So it's a very good setup. We've had a lot of success with those types of episodes, so we're looking forward to it. We have Geopyörä. I'm going to get their CEO to say the name again because he says it with a nice accent. It sounds better when he says it. That's how I say it. And we've got Marcos Bueno on the show. He is the CEO. But then from Freeport-McMoRan, we have Michel. He is a metallurgy manager at Freeport-McMoRan. So, gentlemen, welcome to the show. Great to have you on.
Thank you very much. It's a pleasure.
Thank you. My pleasure.
Marcos, let's start with you. The name is a very cool sounding name, and I can't say it properly. So can you say Geopyörä how you say it, and for the audience to hear the correct way to say it?
Well, so first I'll explain what the name means. So Geopyörä, which I'm not saying like in the correct Finnish way, means geo-bicycle. Pyörä is a word in Finnish which means bicycle. But like I don't say it properly as a proper Finn would say because I'm not Finnish, although I live there and the company was found in Finland.
Oh, you're adding a lot of layers.
Yeah, I will try my best to say first pyörä, which means bicycle in Finnish. And then the geo, they would say without sound of G. So it's Geopyörä.
Geopyörä.
Yes.
I might be getting worse as I try more.
Well, I'm pretty sure that if there is a Finnish person watching this, they're going to be laughing at us. And then they're going to say that we are saying, even myself saying it wrong.
Well, you know what's funny? You're saying about Finnish. I used to do siding in another lifetime, and I got trained by an older Finnish gentleman. And we had some fun times there trying to communicate because he had a very thick accent. And I didn't know anything about what I was doing. So when you combine that, we should have put a camera on us. It was quite the experience, and it was quite dramatic sometimes. But it's great to have you both on. Michel, just wondering, how did you get in touch with Marcos and start working with their company? What's sort of the backstory? How did you get introduced?
Well, I knew Marco from a long numbers of years. So we met in conferences, everything. He was a student at the time, and I was a vendor at the time. So and this is how I know Marco. But over time, we already work in comminution. The comminution experts, it's a small community, so we know everybody knows each other. So we have that part of small people that know each other, and this is what has brought me to my attention because right now he's working on that unit, which is for geometallurgy, and right now when I joined Freeport, right now I'm working on a project. It's our characterization. And our characterization is that you're measuring the things in the lab, and you try to see what is the response of the ore to the process, and the fact is that because we have large deposit, we have to do a lot of samples. So this is costing a lot. And then I realized that they developed that test for geometallurgy, which is exactly what we're doing. And of course, we're always looking ways to be more cost effective and doing more with less. So I think this is meeting our criteria there. And because I was doing a lot of testing, it was a good idea to introduce to have our samples be tested there, because before we need to buy the technology, we need validation. So, and this is why I approach Marco and do a real true geomet program, and with all the samples I have, and in fact, it was to validate, to make sure that it will answer our needs in there.
Let's talk about our Heavy Industry World Tour, brought to you by Savannah Equipment, supplying mining equipment worldwide. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. L&H Industrial can custom engineer and build from the ground up any heavy equipment assembly or machine that you need for your operation. Their worldwide 24/7 field services network is on the job whenever you need heavy equipment troubleshooting, repairs, rebuilds, relocations, or replacements. And thanks to their specialized design and engineering and state-of-the-art manufacturing and repair services, they are a go-to international supplier for improved components and custom assemblies for heavy industrial machinery. Visit lnh.net to learn more. LiveMine is the data management solution for the digital mine, making mining operations paperless through an intuitive and easy-to-use app developed by mining professionals with decades of real-world experience. Trusted by operators in 7 countries across the globe. Get better and more accurate data faster than ever and throw away your paper plods, PDF printouts, and shift sheets. Visit livemine.com.au to learn more.
What I just like to offer the audience some understanding of before Geopyörä came onto the scene. How were you doing it? What would be the common way to do it?
That's a big question. So what happened is that, okay, so basically we're receiving 75 kilos of ore, 100 kilos, and what happened is that we have to select rocks, we split that, and then we send that to the lab, and we're testing that. It takes 2 days or 3 days to do the test work, So it takes a lot of time, lot of efforts to get those, what they call comminution results. So, and the fact is that in his, you just have to pick a few. It's done quickly. It's breaking. And what I like from the unit is that it's really measuring the energy. And usually we're not measuring the energy. We're measuring a product size distribution. We think that the energy will be that. And then we related that to a result, but we're never exactly measuring the energy. And I think this is a new innovative way to exactly measuring the energy directly from the ore. And this is, and that, I think that was unique, and we needed to test that.
So is it? And I know this is sort of like a shameless plug, but I'm trying to just trying to make sure I'm getting it accurate. So your process was actually more expensive, but for less accurate results. You're sort of still making assumptions about the results.
That's right.
Right.
That is correct.
And so, no, please go ahead.
Yeah. So, and it's because all the all the models that we're using, even in there, it's based on a empirical model. Okay. So we have something, we benchmark something, and then we try to fit a relationship to it. And what was different with the Geopyörä is that they were measuring the energy to break the rock. And what is very particular is that is measuring the energy on every single rock. And that is interesting because what happened is that we're gathering all those 75 kilos. It's a lot of section, but at the start, we don't know if the hardness is the same through that 75 kilos. And what it showed me is that he can say that, that rock was softer when we tested that. This one is softer, this was medium, this was is hard. So finally I have a blend, which I didn't know I had. So, and this is very interesting. I think this is something innovative that it brings to industry that I can validate as, I have a, I have a blend, but right now when we try to model, we try to avoiding blend. We want to have pure single hardness, single properties, because this is what we can model because there's no variation into it. And in fact, the test was helping to validate for me, to say, is it a blend or is it not a blend? And this is very important for modeling. And this is what I think is pretty new to into the industry.
Thanks, Michel.
Yeah. So, Marcos, maybe just walk us through. Maybe from your side of the conversation, was this one of the first big projects that you got to work with a company like Freeport on, or what was sort of what stage of the company was it when you got to collaborate with them and Michel?
Yeah, we had done already a fair bit of test work when we did the work with Freeport. Was not the first. We had the first adopter was actually when we were still incubated in university, not found the company, and we were not in the market. Was with Agno Eagle, Kittilä mine in Finland, And we did several other test works and doing comparative because people want to gain confidence. First answer, although you're innovative and you're doing things better in a way that you're directly measuring the energy requirements, you are doing it at a lower cost, faster, with smaller samples, but still people want to show if your result is equivalent to the traditional tests. And we did extensive validations and with collaboration with many customers, such as Freeport was one of them, but we had done also with others such as Anglo and First Quantum Minerals and several others. And the idea was always to do these comparative trials, but Michel went one step further in this Freeport work, which was not only do a comparative in the name value, basically our capability of predicting the parameters of the old school test work results, but also looking what else our tests can give more than the other tests. We obviously deliver very good equivalent results as the other tests in terms of these average parameters that they produce. But our raw data, our actual measurements of a breakage energy and breakage force, which, as he said, we do particle by particle. So if you have a sample normally has 30 to 40 particles. We are going to be doing individual measurements on each particle. And then you end up with a distribution because there is no rock equals to another rock. And then you have these distributions. If the distribution is too wide, then, as Michel said, is an indication that in your sampling, you're not only sampling ore type A or ore type B. There is some sort of mixture in that sample because you can get particles that are way too hard and particles that are way too soft. And if you had done a more precise sampling on an individual ore type, you wouldn't see such a wide distribution of results. You would have a more narrow distribution of results when you're doing the Geopyörä. So this variability across samples and intra-sample, within the sample, is something that's unique in the Geopyörä and allow us to very easily compare samples using classical statistics and also machine learning to differentiate different ore types.
Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymont's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com. The mining industry is navigating a significant transformation driven by electrification, critical mineral dependency, and net zero targets. But balancing daily operations and capital projects can be overwhelming. Burns & McDonnell is your trusted EPC partner, supporting projects from concept to completion. With more than 125 years of experience, they stand ready to help the mining industry meet the demands of the energy transition. Visit burnsmcd.com to learn more.
Michel, I know just we're a little limited on time with you, so I want to ask this question because we've had this conversation in so many different ways on the show about mining companies adopting new technology, the process, the old saying for first to be second and all this sort of stuff. What is the process? What was the process like for you to bring on this technology? Was it fairly straightforward? Was there enough validation right off the bat? Did you have to do internal validation on data that you already knew?
So I still have to do to go to an internal validation. But in fact, what Marcos didn't know is that Agnico Eagle is a company from Quebec, and I know them very well, of course, and they were recommending me to use that. So this is why I went for that technology. There was a recommendation. So when I designed my test work program, I make sure that, and for me it was very easy to get what he was requesting. So, and it was not adding too much. It was adding no cost to me to select the samples, except to pay for the test work, but even the test work, it's a glitch in my whole budget. So for me it's nothing. And this is, and the fact is, like he said, we have to validate to the previous old school test work, or what is the standard in the industry. But I think that it can bring something more, and I think I was very interested in there. So and this is what I was really looking for. So, and this is how I came up. I contacted Marco that what can I do to test your ore here in North America, because basically he had no unit there, so he shipped the unit to one of the labs I was working with, and I think the lab has accepted that. I think it was very keen for him to make it possible to do it in North America, because I was on a very tight schedule, and the problem wasn't the money, it was a tight schedule, and he did answer that. So I think that was really appreciated.
Yeah, I think Michel touched on a point that is very important to highlight, that we were in an early stage. Now we already have established ourselves in a network of laboratories around the world. But at the time, we still haven't had any unit in North America. And these laboratories, because it's a new technology, they will only put your technology in their lab to offer it as a service if they already see a demand for your test work. And but for the lab to see that Freeport was interested in using the technology and doing the test work was what actually opened the doors for us to make an agreement with the laboratory SGS in Lakefield, Canada, and commission the machine there for them to start using it. And then after this work with Freeport, they already did other 2 test works, like one for Rio Tinto and one for Norge Mining as well. So it was the start of the operations in North America.
Oh, and it was done through SGS.
Yeah, through SGS Lakefield in Ontario.
They've been on the show. So yeah, that's very, very interesting. So Marcos, then sorry, Michel. So then that was done through the SGS lab?
That is correct.
Right.
Yep.
Okay. Michel, thank you so much for coming on. I mean, you can write a line or 2 review, and that has some power, but I don't know if there's anything better than a client coming on and saying, yes, this does work, we've used it, especially a great company like Freeport. So thank you very much for doing this. It was great to have you on. I hope we do more episodes and maybe get you back on again a little longer, and maybe look at some other technologies that Freeport's adopted.
Yes, no problem.
Right. Thank you very much.
Thank you very much. It was a pleasure. So.
All right. Well, good to still be sitting here talking to you. We just had to reset there. That's very that's a big win that already clients are willing to get on camera with you. He mentioned he knew you from when you were actually in school. So had you worked with him or some sort of collaboration at some point?
Yes, so we, as you said, the community around mineral processing is more specifically in our field of comminution, which is crushing and grinding specialists. It's a very small field, and we get to know each other. So when I was doing my PhD and started to attend international conferences and events, then I get to know more people, and Michel was one of them. Actually, there is a conference which is the Mecca for comminution people in Canada, once every 4 years in Vancouver, called the SAG Conference, and that's where we all kind of congregate once every 4 years.
Yeah, I've been to that actually. It was a few years ago. I need to go back to it. You went to, where did you get your education? How did you even get interested in this particular field?
Well, that's long ago. So I got my bachelor in mining engineering in São Paulo, University of São Paulo, and continued to work there for Yamana Gold. And with 2 years of career, I decided to pursue a PhD in Australia. I was offered a scholarship to go to the Queensland University at the JKMRC Research Center. And I did a PhD specializing in blends in comminution, in grinding mills, autogenous mills, simulation of different blends, which we call multi-component grinding models. That's how I started to get interested in the effect of blends and characterizing hard, soft rocks and the effect of mixing them in different proportions.
I saw in your bio you also won and I don't know what the award is, so I'll let you just sort of say it. You won the Ian Morley Prize, which as little as I know it's a fairly prestigious award to win. What is that? What is that for?
It's an award given in the University of Queensland in the Julius Christian Minerals Research Center at the JKMRC for students that have achieved higher grounds in terms of their research and breaking research, and that's an award that's given selected one student every year to be the recipient of the Ian Morley Prize.
What do you, the success you've had, and coming out with a new technology and changing the way things are doing it. We'll get into how that's actually affecting the industry. But where does that come from? Did rather than just going to school, getting a job, sort of going through the day to day, that obviously wasn't what you wanted to do. Where does that sort of drive come from to just,
Well,
literally make something new?
yeah, all innovation, it's there to address a pain. And working in the industry was living with this pain of lack of data around rock hardness. So I was working for a Zenk engineer for most of my career. Since like halfway through the PhD, I was working there at the headquarters in Brisbane. And we were working designing grinding mills and to define the design criteria and size these mills and guarantee performance through the life of mine, I thought was a bit of a long shot with a handful of data points. And that was always bothering me. And I wanted to find reasons why it was done that way. And people use the traditional methods, as we were mentioning here before, where you need a large sample. They end up like getting some composite blend samples to test. They hope that these blends are representative of the mill feed during the operation, but sometimes it's not. In many cases, like you have problems of projects not achieving nameplate throughput. And my view was the solution was to do more testing. And but to allow people to do more testing, I need to figure out a lower cost way of doing this test work. And actually, I had the idea when I was still at the PhD at the university, bouncing ideas with a colleague of mine, Rajiv, who still works for Ozenko now. And he was a co-founder of the company, and he's an inventor of the technology, which is a patent technology, together with me. We had the idea when we were discussing the limitations of the existing test on an informal chat, like at the lunchroom. And then, but that idea stayed in the freezer for a while because we were both busy with our careers. And I only managed to pursue it when I kind of drop everything to pursue it myself.
Wow. So did you like fully stop working and just like, how did you get like the actual start?
Yeah, well, first of all, like there was a time I had some personal things happening in my life that I decided to take a sabbatical and cycle around the world. So I spent nearly 2 years traveling around the world on a bicycle. And that's when I had the click that I had to develop it. That idea was for too long in my head, and I need to actualize it. And then coming back to Australia, where it was home for me at the time, I resumed my work at Ozenko, but I didn't last 3 months. I went to my boss, Greg Lane, who I appreciate a lot, the mentorship that throughout my career, and I went to him and I said, "Look, Greg, I have something to say." And he said, "What do you have to tell me?" I said, "I want to quit." And then he laughed profusely, and then he said, "I knew you would do it. Like, but what you're gonna do now?" I said, "Well, I'm going to develop the breakage test that I had told you about." And said, "Well, if there's anything I can do, I can help you." But then I spent another few months cycling around Australia and looking for jobs at universities because I knew I had to go back to academia to do the required research and develop a prototype and develop the technology, which was only an idea. To go from an idea to go to technology takes research. And I found a job in Finland. So there was a position for a mineral processing lecturer researcher in the University of Oulu to help in the Oulu mining school. And then I went there. They had a different scope of project for me to work there, but I had the opportunity to pursue other research goals if I raise funds. And on my first year, I applied, put a proposal for Business Finland funding scheme called Research to Business, and I was awarded nearly $500,000 in funding. I built a team and was slowly transitioning myself from the other projects and delegating them to other people and focusing 100% in the development of what was so called at the time the double wheel breakage test, which when it was ready, then I baptized it the Geopyörä because there was so much about bicycle in the design of the machine. I don't know if you can see there in the background, but it is 2 wheels counter-rotating. The whole frame resembles a bicycle. The whole concept also of energy transmission and so on has a lot to do about bicycle. And I'm a passionate cyclist, and so I had to call it the Geo Bicycle. And then because I was in Finland, so I called it Geopyörä, which is bicycle.
Wow, it's amazing. It's so you really did the idea for the bicycle design come while you were cycling, or was that just when you started to think, okay, I'm actually going to do something with it, or did the actual concept come from cycling?
Well, the concept comes to use at the time we were thinking about using rolls crusher. Roll is different than a wheel because a roll is a roll, so it's very wide, but the diameter is not as big. And then, but then I saw the work of a researcher trying to do it, and I said, no, that's not the way. But then the idea of having a bicycle design came during the trip, and then I basically came from an idea which was to use a rolls crusher to go into using two wheels to crush it. And then the whole design, I also have to acknowledge that there was a lot of input from a brilliant Finnish student who was my student. I was supervising him, Jone Torvela, and then he put so much creative input in the design of the machine as we know it today that he's also a co-inventor in the patent that we filed.
Marcos, I just want to sort of pause for a second and actually walk the audience through. You've got a couple of videos on YouTube. I want to bring at least one of those up and just walk us through. You already referenced, the bicycle design, but just walk us through how the product actually functions and it works. And we'll bring up a video to match up with it as well.
Right. Well, thanks for the question, Garrett. So the Geopyörä was designed to use two basic principles. It crushes individual rock particles between the counter-rotating wheels, and when the particle is going to be dropped to be broken, the motors are switched off so that we can measure the energy consumed in breakage without any interference from the motors. And this energy consumed in breakage is quantified by the loss of momentum of the rotating wheels. So the motors on the wheels, they are gearless. So they are integrated like electromechanical motors. So there is no mechanical gears. So when we switch them off, the wheels are coasting just spinning by inertia. And then when the particle drops, it breaks the rock, decelerates the wheels. So basically is energy being transferred from the wheels to the rock. So we can quantify very accurately the energy that's used to break each individual rock. In contrast, like a traditional method such as the drop weight test, it puts the rock specimen on an anvil and then they adjust the mass and the height to provide a nominal amount of energy, but we don't know exactly how much energy was actually consumed in the breakage event. You have to assume that all the energy that you input was used. But in our test, no, the energy is measured and is an output, is a response of the rock hardness. So if I have the same gap, we are passing rocks that are harder and softer. The harder rocks will give you higher energy levels than the softer rock. And that's in the energy measurement side of things. But the machine also measures the force, the breakage force. So basically how much force it takes for the rock to collapse, to break. So in one of the arms of the machine, which resembles the forks of a bike, we have strain gauges. Placed in where we have a concentration of tension in the bin. So when you are breaking the rock in between the wheels, this force response, we capture it at very high speed. Sensors that capture this force building up to a peak, and then the rock collapses, breaks, and then the force obviously fades away. So you can capture this peak force for fracture, and that's what we use to derive all the geotechnical parameters such as the UCS, the Unified Compressive Strength of the rock, or the Point Load Test Index, which comes also from another test. And the energy relationship with the broken product. So the broken product, we can analyze them when it's free falling with image, or we can only collect it and do mechanical sieving. And then the fragmentation is correlated with the energy, the breakage energy to derive the comminution parameters.
Wow. How does this change the way that the industry is approaching things? Is it like you're doing this breakage test now? How much do you see it actually shifting the information, how the information is collected, but also just how then mining decisions will be made from the information collected?
Sure. We see it as primarily as a tool of risk mitigation, but then it also gives you the opportunity to do optimization exercises to add more value to the projects. So traditionally, as we were saying, they only test a few samples and they get some reference, some idea, some with a lot of uncertainty about how hard that rock is going to be throughout the life of mine. But then they put some safety factors in design, and then they hope that that was going to be able to process at least 80% what's under the ground throughout the life of mine. But then in many cases, because you haven't tested enough, you can have surprises. And the thing is that with grades, when you're talking about defining mineral resources, you're assaying every meter of drill core taken out of the ground during the exploration phase. And normally they take kilometers of drill core, typically about 100 kilometers. So you're talking about 100,000 assays. And there is a lot of procedures of QA, QC, where you need to do repeats, all defined by the security exchanges, such as the NI 43101 policies in the North America, Canada market, or the JORC code for the Australian Stock Exchange, where they define these policies so that there is no fraud or no risk for the investors when they are investing in a mineral reserve. So they have the inferred reserve, the measured reserve, and there is very thorough statistics and sampling and testing around measuring the ore grade. But when it comes to the engineering phase, everything comes down to the signature of competent persons, like engineers that have experienced engineers, which are designing that processing facility and estimating capital cost, operating costs, and the performance of that asset throughout the life of mine to define an NPV for the project. But that is done with a handful of data, and that's where I want to make change. I want to make change where we are going to reduce the uncertainty with more samples tested, and now there is no excuse that the test is expensive. Just to put in a perspective, traditional testing methods, you would have to do multiple tests, and they all take a long time. They cost thousands of dollars to test a sample, one sample. And with our test, costs a fraction of the cost. You can go as low as $15 if you are doing the high volumes. And then you can test way more samples, have way more data, and then which will give you more certainty on what you're going to come to process throughout the life of mine. And then you'll be able to have a more accurate decision on your main piece of capital asset, which is your grinding mills. And also they are going to dictate the whole revenue of the mine throughout the production. The tons that pass through the mill is metal produced. So if the mill is not performing, is not producing tons, means that you're not actualizing the revenues that you disclose to your clients. So that's the prime a change that we want to do. But there are more.
What is the main challenge to get this? We're throughout this interview, we're bringing up interviews. You've got a great one where there's a core resources video that we're going to bring up that actually shows the rock passing through the wheels. Would you call those the wheels? Because they're not really
the wheels. Yeah. The wheels.
What is the main challenge you have getting to market? Again, we've had people that have newer technology. They don't come on with clients, and you sort of pitch it. You've already got a client on, so you're 10 steps ahead of most people already. So now in this market, not sort of much where the challenges were, but today, what is sort of the next stages? What do you need to accomplish in the industry to sort of get it available to everybody, educate people, get the adoption? Where are you sort of at that in this stage?
Right. Yeah. So the very first stage, which we mentioned when we had Brissette here, was the validation. So for them to get confidence that our tests produce equivalent parameters as the other tests. Just to put in perspective, when you say other tests, the two main tests is the Bond test, which was developed by Sir Fred Bond in the 60s. And is still being used out there extensively, which is a grindability test. It's more like a drum mill where you grind material in the lab. And then the other test to measure another parameter, which is an impact breakage test. The most used technology is the drop weight tester, which was introduced in the 80s. And one of your guests also talked about the SMC, which is the leading market technology. Like Steve Morrell introduced that, a simplification of the drop weight test in the early 2000s, and it's very successful and it's being used extensively, but still very laborious, and they cost a lot to do. So the first challenge we had was to show that our results line up with those. So most customers, they were coming to us with a few tens of samples or a couple of hundreds of samples, and then they would do the traditional test work, bone test with SMC test, and then they would do our test, and they would compare results. And this type of exercise we already did extensively, as I said, and we already have a database of nearly 800 comparative tests, and they are pretty much all aligned up and they are close to each other. So I think we already turned that page, saying that we provide equivalent results from the traditional test work. But now the main challenge is to go one step further and then to embrace our mentality, because they still very much caught up in the old school mentality where they're gonna take big samples. And my whole proposition is to use small samples. So they are used to, because the old test, they need big samples. So to make big samples, you end up mixing rocks, end up mixing apples and bananas. And then when you do when you're trying to do a characterization, a rock breakage characterization, you need to characterize the breakage properties of the apple and the characteristics of the banana. You cannot have mixtures. You cannot do a test where some of the particles that you'll be taking the test will be of one property and the other will be from another property. So you need to characterize these components, these ore types individually. So to do that more precisely, we propose to use small samples, and we want to use the same samples that are used in assay labs, which we will never do an assay to see elemental composition of a rock on composites of more than 1 meter of drill core. They are going to take they're going to do the assays meter by meter, because they don't want to mix materials. And our test was designed in a way that you can use that 1 single meter of sample. And that shifting mentality is becoming the challenge now. And a few customers already went that second step with us, and they are doing the test work as we prescribe, with our mentality embraced, where you characterize the rock in single 1 meter intervals, and then you can really see the variability rather than masking it. When you are blending, you are masking this variability, you are blurring it, and then the idea is that we want to highlight it.
So, Marcos, really simple question. What's next? Where do you want the company to go? Where are you already taking it? Do you already have new things in development? Where are you going with this very interesting company?
Thank you. Yeah. So we've been already being successful in establishing ourselves as an alternative to traditional testing in the laboratory environment, which we call offline testing, because customers have to get samples, sent to a lab, get them tested. Although we do it much rapidly, we get the results immediately. The vision when developed the Geopyörä was always to have something that would allow an innovation that everybody was wanting. It was kind of the holy grail that everybody wants, but none of the other laboratory technologies would allow it, which is to do real-time hardness measurement on a mine site. And we already raised last year 200,000 euros to do a proof of concept, which was a great success. So a machine that can do everything that a laboratory technician usually would put the rock pieces in the machine to let it be tested, put it in the feeder. So we created a robotic system that gets a batch of rocks that comes from a sampler, and then we'll test them automatically so that we can generate results in real time. And then we are going to characterize the breakage properties, what is the composition of the rock with XRF sensors and hyperspectral imaging to get some mineralogy indication. And that's what we're calling the Geopyörä rock, real-time ore characterization. And we are pushing this innovation. Now we are applying to the EIC accelerator funding in Europe, which is, they call the Olympics of startup funding in Europe. So it's very competitive, but we are very confident it's going to raise 3 million euros to develop like this technology and bringing because the Geopyörä lab technology is already TRL 9, but this that we just did a proof of concept is at TRL 5. So you're gonna cover this funding will cover the bridge and development of an MVP and bring it to TRL 8, and that's like the journey for the next like 2 years.
So conceptually, and you're confident of the viability of it. It's now just getting sort of funding in place and going through that process of getting it ready for market.
Yeah, exactly. So now we need to develop like a product because we have this kind of prototype, like a proof of concept. There are things that we need to improve, like in the mechanical design, in the hardware, software, and we need like to hire more people into the team, and we are gonna need like those resources. And it's a 2-year project that we are planning and applying for this funding to run this project for the next 2 years.
Wow, it must be an unbelievable feeling and you've kind of got an interesting story. Like you took 2 years on a bicycle to ride around. I have to ask that must have in a way changed you. I mean,
Yeah, it did.
I mean, if it's if that's a personal question, I don't of course I don't want to push it, but how did you? Who were you when you started that 2 years? I mean, I cycle a bit. 2 years cycling there's a lot that goes into doing that. There's just a lot. What changed you over those 2 years? And did any of that sort of just the discipline and the patience it takes to do that? That must have sort of helped in developing this product. I'm making an assumption, but I'll let you tell me.
No problem. Like I'm more than happy to talk about it. So I was in a kind of cross section of my life, like a crossroads. I had just divorced from my ex-wife, and I had this dream of doing this around the world trip. The dream would come like from my very young ages, like when I did my first bike trip in Brazil when I was 19 years old, like about 20 years ago. And then, but I left that dream kind of on a draw because life goes on. You have like other responsibilities and so on, a family and so on. And then, but after the divorce, I said, "Well, now is the time. Now I need to do it." And I went for it, and I did it, and really was in a phase where I was pursuing more yoga meditation, and I tried to blend the whole cycling with yoga meditation in the sense of like it's a tool for you to realize impermanence and get going without, despite of like the highs and lows of life or what's going on with you. So like it doesn't matter if you're having a great time or a bad time. You just have to keep rolling, and that like gave me like a really mental strength, which now I take like that into the entrepreneurship, like as an entrepreneur, which is very challenging, like to start a business, and coming from always working for corporations or in the academia and then starting a business, that like resilience has helped me a lot in the entrepreneurship journey, and also in my hobby, which is still cycling. And now I do ultra races in my spare time. Like so, I did like races across the America and races across Europe, and I like to push the limits on cycling.
Well, cycling is a great for anybody who hasn't done. I mean, we've all ridden bikes, so going up a hill. But when you cycle, there's a unique thing that happens when you're going up a hill is that you cannot stop. In everything else, if you're running, even if you're cycling on the flat, you can kind of coast. Cycling uphill, it does not matter how tired you are. It doesn't matter how hot the sun is. You have to keep going, or else you just stop. And it's a great way of looking at being an entrepreneur. It just all stops if you stop. But I noticed that you went back. When you went back, you tried to work for a company for a few months, and then you realized no, you kind of went back to that freedom just in business rather than on a bike. It's sort of what it seems like to me listening to your story.
Yeah, indeed. Like I already came with the mindset of developing it, and I came first because when I left to do the tour, I didn't quit my job. So my boss at the time, Greg, like he was fantastic, and they understood me completely, and they gave me a long-term unpaid leave. So I had my position there waiting for me, basically. So when I came back, I had my desk there. I just started doing the things as per usual. But the thing was that I could not develop the technology while doing the work. It became clear to me that I was either or. I could not dedicate myself to the level I had to develop, which was just an idea, and developing into something real while busy Monday to Friday, 8 hours per day, working on engineering projects. So I had to quit my job and dive in 100% into it.
Yeah, it's absolutely amazing. Like, so just to give you an idea, like we have people. We had a train company on today. They've been around since 1918. We've got companies that have been around over 100 years, and then companies like yours that are new. They're changing the way that people will do things. We have so many episodes about trying to make mining more efficient and safer and all that. And seeing someone like you just your story, it's just an interesting thing. And seeing also people watching to, if you think it's hard to innovate, and it is hard, but has it been rewarding going through all this? Has it been rewarding getting it to this point?
Well, I think it's as we say, in ultra cycling, it's the type 2 sort of enjoyment or fun. When you're doing it, you don't know you enjoy it that much. But then after, when you look back, say, yeah, that was really enjoyable. That was really good.
Yeah, no, it's so exciting. I hope we're going to I hope you're going to come back on the show again, because I know that the company's just sort of getting started. It's to market now, but there's lots of places you want to go. So please come back and get us updated. Maybe if I'm in person at an event, it'd be nice to actually sit down and talk and just maybe take a little bit more time to peel back some of the development, because I feel like this story is just getting started. So thank you very much, Marcos, for coming on the show.
No worries.
And thank you, everybody, for watching. Of course, we're going to put links to Geopyörä in the description. If you're watching from maybe like LinkedIn, you can tag. There'll be a tag. You can follow them right on LinkedIn, or you can connect directly with Marcos. He's on LinkedIn as well. And certainly take the time to do it, because one, it's a very interesting company, and two, we want innovation in the industry, and they exemplify it. So thank you, everybody, for watching. We will see you on the next episode of Mining Now.